State's 2018 First Year Engineering Design Day. As you can probably tell from our name, we were assigned to build a fountain. Using the engineering design cycle and countless hours of trial and error, we created the afternoon session's winning fountain. The first step in our project was to ask. That is, to ask what the problem is. We concluded that the main focus was to create an aesthetically pleasing liquid fountain that had the application of one of three required engineering concepts. The next step was to imagine what the fountain would look and perform like. This step took the longest, as we transitioned from idea to idea about design. Originally, we planned to build the fountain in a carved-out piece of styrofoam that would be roughly 2 cubic feet. We went through several iterations of this idea before moving past the idea altogether. After a great deal of consideration, we focused on a bucket design with laminar flow as the main engineering component. We then planned to build a nozzle based on a tutorial we found on YouTube. The nozzle was to be made with PVC piping and sections within the PVC piping that slowed the flow of water. The plan was to make the water less turbulent in order to achieve the laminar flow pattern. Additionally, we planned to cut out a piece of styrofoam as the support for the laminar flow nozzle and as the decorative base of the project. To create the actual fountain, we ended up tracing the open side of the bucket onto a piece of styrofoam and spent an obscene amount of time cutting it with a small bread knife. Whittling down the base allowed us to set it about an inch below the top of the bucket, where it supported the weight of the upper half of the nozzle. The water stream shot into a hole in the styrofoam that sat on the other side of the nozzle. When it came time to address the final step of the engineering design cycle, we looked to improve the fountain's aesthetics. We resorted to using acetone to eat away at the styrofoam, giving it a rugged texture that resembled an Arctic landscape. We then painted the bucket, styrofoam, and nozzle white and added Arctic animal figurines to top it off. We focused more on functionality than design, which seemed to have paid off.
The first design challenge that we addressed was the size limit of a 2x2 base. We had to shrink our original styrofoam design, as seen in the picture on the screen, to a smaller scale to fit. After we abandoned the design, we ran into another challenge when we reached our first functioning model. When using acetone on the styrofoam, we ate away at too much of the base and weakened its structure in addition to compromising the aesthetic. Then, we added fake leaves and rocks, as seen in the picture to the right. The dye in the fake leaves began to soak into the acetone parts of the fountain. To hide this issue, we tried using spray paint to color the styrofoam white for our Arctic theme. Turns out, the spray paint also had acetone, and it further ate away at the surface we used on it. Now it simply looked too jagged to be an ice landscape. Functionality-wise, to make the laminar flow look smooth, we went through trial and error testing different angles for the nozzle to minimize splashing and to ensure a continuous stream. Our research project focused primarily on the history of fountains, how they came to be, how they progressed with technology, and so on. Few things to mention are the invention of the Roman aqueducts system and the patents of recent fountain manufacturing. However, the most interesting part of our research component was surely the explanation of laminar flow and how we learned about how we could achieve it. We would have to give the water a structure to pass through in order to calm its turbulence. That structure came from the form of straws, screen door mesh, and Lock-Brite scouring pads. These structures which slowed the water down and end up helping us to achieve a calm laminar stream.
Our fountain project got first place out of the 18 fountains that were competing in the afternoon session. Walking around FEDD, we noticed that our fountain was not the most creative, but it was the most functional and efficient. What our group would have done to be more efficient would be to make a better schedule with realistic goals for each week. Our schedule did not include goals for each week, which is something that led us to have some unproductive weeks. We then had to cram in meetings and build days the closer we got to FEDD Day. Our advice to next year's groups for FEDD would be to stay on top of things and to make sure that you stick to a schedule. This is not a project that you could successfully complete on the last night, so you better make sure that you schedule in times to meet with your group every single week. Additionally, stay open to all ideas because we couldn't narrow down a functioning model or design until we had all brainstormed a few ways to build it. Finally, don't be afraid to deviate from what you originally plan on. The best new ideas often happen when you're focused on how to improve what you have already made.
At this point, we'd like to give a shout out to Miles Robinson for being an amazing E101 teacher throughout the semester. He gave us important parts of engineering that we would have otherwise missed out on and helped us prepare for FEDD Day in a great manner. Additionally, if you have any questions, feel free to email us. And that's it.